My name is Kyle Dart and I attend Baskerville Wills High School, and this is my video submission for the Skills USA Aviation Maintenance and Technology competition. The question I was given was, using a sample general aviation 4-passenger aircraft pilot operating handbook, compute the weight and balance of a sample load of 1 pilot and 1 passenger with full fuel at 5,000 foot density altitude, and also compute whether this aircraft can safely take off within CG using a 2,500 foot runway. So for the first section of this, of the question, I use a weight and balance chart from a Cessna 172 found in the pilot operating handbook. And using this chart, we can see that the empty weight, we can fill out the chart and find our total weight and moment. So we can see that the empty weight is 1,454 pounds. The total usable fuel weight is 240 pounds. The pilot and front passenger, we're assuming, are 170 pounds each, so their total weight is 340 pounds. And we're going to zero out the baggage and the rear passenger because they are not mentioned in the question. And then we're going to move on to the moment, and the moment is in thousandths, and we can find the moment by multiplying the weight by the arm or station. So the empty weight moment is 57.6. The moment for the usable fuel is 11.5. And the moment for the front and rear passengers who have a station of 34 to 46 is 12.6. And if we zeroed out rear passengers and baggage area. So we add up our columns to get the total weight. So we do 1,454 pounds plus 240 pounds plus 340 pounds. And we get a total weight of 2,034 pounds. Now we add up the moment, which is 57.6 plus 11.5 plus 12.6, and we get a moment of 81.7. So using this center of gravity moment envelope, also found in the pilot operating handbook, we can use our total weight and our moment to see whether or not it fits in the normal category and is within CG. So we have our total weight of 2,034 pounds, so around there, and our moment of 81.7. And when we bring those together, we can see it is well within the normal category. So this aircraft is within CG. Now for the second part of the question, we're going to use the performance charts for the 172, also found in the pilot operating handbook. The performance charts use pressure altitude instead of density altitude, and in the question we are given 5,000 foot density altitude. So we're going to make some assumptions about the pressure altitude and the temperature to get the density altitude. Density altitude is found by, so this is density altitude, it's found by the pressure altitude plus 120 times the difference of the outside air temperature and the international standard atmosphere. So that's how we find density altitude, from the pressure altitude and the temperature. So to get a density altitude of 5,000, we can say that our pressure altitude is at 4,400, and our outside air temperature is at 10. So we have 120, 10 minus the international standard atmosphere, and at 4,000 feet, or around 5,000, our international standard atmosphere is around 5. So we would get, you'd get 5 times 120, which is 600, plus 400, 4,400, and we would get that equal to 5,000 foot density altitude. So using our performance chart, we can use our pressure altitude of 4,400, and we can see our weight is closest to 2,100. Our pressure altitude is between 4,000 and 500, and our outside air temperature is 10 degrees Celsius. So if we look at our chart, we would only need between 4,000 and 5,000, we would only need 1,600 to about 1,800 feet of runway to safely take off, and that is well within the parameters of the question.